Good day, ABM student. This is lesson 2 of the estimation of parameter. And lesson 2 is about the confidence interval and the central limit theorem. Let us have these terms. Confidence level, expressed as percent. It sets a portion of the samples to be included within a known range of the true population. It is said to be the level whereby the researcher is confident, okay, that that these data are the true population or the true parameter or the true value. Okay, confidence interval, okay, the width, positive or negative 2.9% stated as plus or minus 2.9 when the interval and confidence level are put together. You get a spread of percentage. In this case, you would expect the result to be 35.1%, okay, 38 minus 2.9 to 40.9% or 38 plus 2.9% of the time. So later, maintindihan ninyo yung pinapaliwanag dito sinasabing confidence interval. Okay? So ito yung makukuha natin dito yung range of values. Okay? So kung makikita ninyo, maraming value dito. Okay? So ang papaliwanag natin later bakit nag-minus ng 2.9 at bakit nag-plus ng 2.9. Okay? So it is the width. Okay? It is added doon sa ating mean or yung sa ating point estimate. Okay? So later makikita ninyo kung paano natin yan gagawin. Okay? Let us have this illustration. Okay? The graph shows that 95% of the population distribution is contained in the confidence interval. Okay? A confidence level of which is, hindi siya 1, which is 95%. Yung 1 natin is the total area of the curve, under the curve. So, lahat ng included dito sa curve, kasama yung tail. Okay, may tail yan dito. Kasama yung tail, lahat ng area na pasok dito sa curve is equal to 1. Okay? Whereby yung confidence level ay 95%. So, sinasabi dito na yung researcher is very confident na doon sa data na hawak niya dito, sa area na to, 95% yung sinasabi niya na sigurado na true value ng population. Okay? So, we have here the alpha or A is equal to 5%. So, paano nakuha yung A or yung alpha na 5%? Okay? So, yung 5% is the opposite of the confidence level. Okay? So, ang confidence level natin ay 95%. Okay? Yung opposite niya ay 5%, which is what we call the significant level. Kung ito yung confidence level, ito yung significant level. So, how significant it is? Why? Because this 5% is what we call the margin of error. Okay? So, ito yung 95% na confident ang researcher na tama yung data na nakuha niya. Okay? Very sure siya na itong 95% na to pasok doon sa research na ginagawa niya. Okay? Itong value na to ay true value. Okay? So, naglaan siya ng margin of error. Ito yung part na kung saan alam niya na very, kumbaga, hindi siya sigurado or confused pa siya dito or hindi niya sinasabi na ito ay tama or totoo, kumbaga, o pasok doon sa kanyang level of confidence. So, nag-set ng level of confidence yung researcher, and then yung itong naiwan na to, these are the error or the significant level o yung sinasabi nating margin of error. So, naglagay siya ng margin of error para kung mayroon mang pagkakamali, yan, maialis na natin. Okay? So, hindi confident ang researcher dito sa level na yan. Okay? So, inaalis natin yan para makuha lang natin yung true value, which is 95% of this data. Okay? So, 5% is the opposite of 95%. So, kung ang curve ay equal to 1, so ibig sabihin 100% yun. Of 100%, 95% lang yung confident ang researcher na tama yung data na nakuha niya. Okay? So, alisin natin yung 5%. Okay? So, kung itong curve ay same yung size, middle bounded, ibig sabihin, dahil ito ay mayroong dalawang tail, so, hahatiin natin yung 5%. So, 5% dinivide natin sa 2, that would be 2.5%. So, may 2.5% dito sa left at may 2.5% dito sa right. Okay? So, kung aalisin natin yan, okay, and hahatiin natin to sa gitna, okay, same pa rin yung size niya, same pa rin yung sukat. Okay? So, yung 95% hatiin natin, that would be 47.5%. In decimal, that would be 0.475. Again, in decimal, that would be 0.475. Para makuha natin yung z-score or z-value ng point na to, syempre titingnan natin to sa z-table. Ang hahanapin natin ay yung 47.5% or yung 0.475. Okay? So, kung titingnan natin sa z-value, yung z-score niya, that would be positive negative 1.96. Bakit positive negative? Kasi, itong part na to, that is negative, at itong part na to ay positive. Okay? So, negative 1.96 and positive 1.96 yung ating z-score. Kaya positive negative 1.96. Kasi dalawang 1.96 yan. Ito. 1.96 to, 1.96 din dito. Isang negative at isang positive. Kaya yan ay positive negative 1.96. Okay? Illustration number 2, using the same method, derive the z-score of confidence level 99%, we get that the z sub a over 2, okay, again, z sub a over 2 is equals to positive negative 2.57 or 2.576. Okay? So, paano nakuha yun? Again, alam natin na area under the curve is equal to 1 or 100%. So, 100% minus 99, that would be 1%. So, yung 1% divided by 2, that would be 0.5%. Okay? 0.5%. So, to 0.5%, i-minus mo dito sa half ng curve. Okay? So, 0.5 minus, this is 0.5, minus 0.05. So, that would be 0.495. Okay? So, 0.495, hanapin mo yan sa z-table. So, makukuha mo yung z-score. So, the z-score would be 2.576. Dito siya sa positive. Okay? So, sa negative, negative 2.576. Again, pareho naman kasi ng size yan. Okay? Positive and negative. Okay? So, ang z-score, okay, or yung confidence interval, that would be positive, that would be negative 2.576 to positive 2.576 or positive negative 2.576. Okay? So, ito yung summary of z-scores for commonly used confidence interval. So, kapag nakita nyo na ang confidence interval ay 90%, that would be 1.645. Kung 95% naman ay 1.96, or kung 99%, that would be positive negative 2.576. Okay? So, let us have the central limit theorem. Using the c-value, okay, it is derived from the central limit theorem. So, this is the formula to get the z-value. Okay, z is equals to the sample mean minus the population mean over the standard deviation of the sample mean, or z is equals to the sample mean minus the population mean over the standard deviation over the square root of n. Okay? The central limit theorem states that the sample mean approximately follows the normal distribution with the mean and standard deviation. Okay? If the population follows a normal distribution, then the sample size can be either small or large. Okay? If the population from the sample is taken from taken follows a non-normal distribution, then the sample size n has to be large. Usually, n is greater than 30. Okay? If this population is, is taken from a non-normal distribution. Okay? The central limit theorem also states that even if the population distribution is strongly non-normal, okay, in sample distribution of means will approximately normal for large sample size or over 30. The theorem makes it possible to use probabilities associated with the normal curve to answer questions about the means of sufficiently large samples. Okay. Okay, this is 1 minus alpha or A. Okay, this should be A times 100% confidence interval for the population mean derived from the central limit theorem as stated below. Okay? So this should be 1 minus A by 100%. Okay? The formula is explained in detail below. So this is the formula. Okay? To find the confidence interval. So we have here the sample mean minus Z. This is A, should be A over 2 or the alpha over 2 multiplied by standard deviation over the square root of n less than the means less than the sample size plus z sub a over 2 or alpha over 2, okay, multiplied by the standard deviation over the square root of n. Okay, the confidence interval, the population mean with a given confidence level of a 1 minus a by 100%, and when the population variance is known. Okay, just to give you the correct formula for this one. Okay, so this is the alpha or the lowercase. It is the significance, the probability of a type 1 error. Confidence is 1 minus a by 100%. So ito yung correct formula. Okay, so that should be 1 minus a by 100%. Okay, so this should be sample size minus z sub a over 2 multiplied by the standard deviation over square root of n, 2, yan, 2 sa sample mean plus z sub a over 2 multiplied by the standard deviation over the square root of n. Okay, this should be a over 2. Okay, this should be a over 2. This should be a over 2. Z sub a over 2. Okay, that is our margin of error. Let us have this example. The operations manager plans to select 300 female employees from a group of tenure workers, where height was considered due to the nature of their task. The selected group has an average height of 170 cm and a sample standard deviation of 25 cm. What is the 95% confidence interval of employees' height? Okay, we have here this solution. We have the given sample size n is 300, mean is 170 centimeter. We have the standard deviation of 25 centimeter. Confidence interval, it has 95%, and an A or the significant level of 5%, and z sub a over 2 is 1.96. We substitute the given values into the formula for the confidence interval. So, substitute lang natin kung ito yung formula for the confidence interval. Okay? So, substitute lang natin. We have here the sample mean, which is 170, minus yung ating confidence interval, which is give us a 95% confidence. Okay? So, ito na yung 1.96. Nakuha natin yan dito sa formula to, Z. That is the Z score of A over 2 o significant level divided by 2. Okay, so yung significant level natin is 5%. We divide it by 2 para makuha natin yung Z score. So, we got the Z score, which is 1.96. Okay, so sinubstitute lang natin. And then standard deviation, which is 25 centimeter. And then the square root of n is 300. Okay. And also do it to the next value, which is sample mean, add the z-score, which is 1.96, and then 25 over the square root of 300. Okay? Yung answer natin dito is 1.67, and then dito naman ay 100. This is 167.17. This is 172.83. Okay? So, yung interval is from 167 to 173. Okay? Hence, the operation manager is 95% confidence that employees have a mean height of 167 to 173 centimeter. Okay? Example number 2, a random sample of 40 resident of Quezon City has an average electrical consumption of 29 kilowatt hour per month. Okay? With a sample standard deviation of 8 kilowatt hour, give the 90% confidence interval for the mean usage of electricity per month. Okay? So we have here a sample size of 40. We have 40 residents, a mean of 29 consumption. Okay? And then we have a standard deviation of 8 kilowatt per hour. And the confidence interval gives 90% confidence, which is equal to 1.645. Okay? So, paano nakuha yon? Siyempre, nakuha natin yung alpha or yung significant level. It should be A is equals to 10%. So, dinivide natin yan sa 2 and then hinanap natin yung value niya sa z-table, which is 1.645. Okay? So, all we have to do is to substitute this sa ating formula. Okay? So, yung formula natin, yung ating sample mean, which is 29. Okay? Yung ating z-score, which is 1.645. And then we have here the standard deviation over the square root of n, 8 over the square root of 40. Okay? So, again, gawin din natin yan dun sa isang value, which is an sample mean. Add naman natin. Kanina may nag-minus tayo. Dito ay nag-add tayo, which is 1.645 yung ating z-score. And then square root over, standard deviation over the square root of n. Standard deviation is 8 and n is 40. Okay? So, yung nakuha nating value is 26.92 to 31.1. So, ito yung ating interval estimate o yung ating confidence interval. 26.9 to 31.1. Dalawa yung value niya, but it doesn't mean na dalawa lang talaga yung value. That is from 26.9 to 31.1. Okay? A sample size of n is equals to 100 produce the same mean of x is equals to 16. Assuming the population standard deviation of 3, compute 95% confidence interval for the population mean. Okay? Confidence, 95% confidence interval for mean is, so ito yung kanyang formula. Okay? So we have a sample mean, the z sub a over 2, yung ating significant level, multiply by standard deviation over the square root of n, o yung sinasabi nating margin of error. So let us have this formula, substitute the given. We have here 16 as our sample mean. We have the z value of 1.96 dahil ang ating confidence level ay 95%. Okay, we have here the standard deviation of 3 and the sample size of 100. So that would be 15.412 to 16.588. So that is our confidence interval. So answer what I can do. Okay, that's it.